We're going to move on to talking about how to factor other types of problems. But before we do that, I want to tell you that you should always begin any factoring problem by first factoring out the GCF if there is one. Your life is going to be much less difficult if you do that. And there's some problems where if you don't do that first, you're just dead in the water. You just can't proceed. What we'll talk about next is factoring trinomials of the form x squared plus a number times x plus a number. So B and C are numbers. And to lead into this, let's start out with a multiplication problem. Suppose we need to multiply x plus 2 times x plus 3. We'll use the FOIL method. FOIL stands for first, outer, inner, last. So first, I'm going to multiply the first two terms. Gets me an x squared. Then I need to multiply the outer two terms. That gives me a 3x. This is just a way of organizing all the distributions we're doing for the distributive property. Next we have the inner terms, so 2 times x. And last we have the last terms. So 2 times 3, which is 6. So that's where that FOIL acronym you might have heard of comes from. First, outer, inner, last. I personally think of it as just going from left to right, but whatever. To get our final answer in simplified form, I will add the 3x's and the 2x's. So my final answer here would be x squared plus 5x plus 6. Now, suppose we're going the other direction and we have a problem that asks us to factor x squared plus 5x plus 6. In other words, we're supposed to write x squared plus 5x plus 6 as a multiplication problem. Now, this is starting to get difficult to do. However, since we just did the multiplication problem, we can see that it would be x plus 2 times x plus 3. But how would we find that if we hadn't just done the multiplication problem? Well, notice that the 2 and the 3 have to multiply to give you the 6 at the end. Because when you multiply out x plus 2 times x plus 3, the last thing you'll get is 2 times 3. And if you want that to be a 6, then the 2 and the 3 have to multiply to be 6. Also, the 2 and the 3 are going to give you those two x terms when you multiply out x plus 2 times x plus 3. And they have to add to give you the 5 on the x in the middle. So the two numbers we see in the parentheses have to multiply to 6, and they have to add to 5. There's a method that people like to use to kind of organize the thinking when you're working on this kind of problem. People will make an X, and up top is going to go the product that's needed, which in this case is a 6. It's going to be the constant term at the end of the thing you're trying to factor. And they'll put the sum that they need, which is going to be 5 in this case. That's the coefficient on the x term. And then the trick is to find two numbers that multiply to be 6 and add up to be 5, which in this case was 2 and 3. Let's try another problem. Let's factor x squared plus 5x plus 4. So to turn it into a multiplication problem, it's going to look like two sets of parentheses with x's in them. And those x's are going to be followed by or going to have numbers added to them. To figure out what those numbers are, I need to find two numbers whose product is 4 and whose sum is 5. So let's see, two numbers that multiply to be 4 and add up to be 5. So if they're going to multiply to be 4, it's either got to be 2 times 2 or 4 times 1. Well, 2 and 2 don't add up to 5, but 4 and 1 do. So those are the numbers I need. Those are the numbers that go in the parentheses. Now remember, you can always check to make sure your multiplication problem, your factorization, is correct by doing the multiplication and seeing if you get back to the thing you started with. So in this case, I would check by foiling. I'd have x squared plus 1 times x plus 4 times x plus 4, and combining the like terms in the middle, yeah, x squared plus 5x plus 4, that's what I started out with, so my factorization is correct.